wire. But this is how you would see it if you're actually looking at a program that's called Wireshark. And Wireshark is used to actually see the data as it's leaving or coming into your interface. If you downloaded Wireshark, which is free, and look at the data on your interface, you will see all types of traffic. It would look foreign to you. You're just like, I don't understand what's going on. Hopefully, after I explain this, it will start to make a little bit more sense to you. So we have our data here. Now I want you to think about, this is PC1. And PC1 is going to send data over to PC2. But he has to build all this information first. So he has the data that needs to be sent. And remember, a header is just something that gets put in front of the data. So the user types in this information, and he's going to put this little bit of information in front of the data. Just this little bit of information. Now, once I put this header here, that means I'm going to see this first once someone looks at it. So that means now the data is hidden. The data is hidden behind this header. Now, once this is done, I'm going to send this down to where? I'm going to send this down to the presentation layer. Now, the presentation layer is going to say, okay, I know how it needs to be presented. Let me put that information in my header, and boom, I'm going to put this little header on top in front of the data. I should say in front of the application header. Then this information gets sent down to the session layer. The session says, okay, I'm gonna build the session, get this created, get this started for you, and it's gonna put its headers on there that are needed. Then he's gonna send it down to the transport layer. Transport layer is gonna say, okay, this is the information that I need to put in there. What do you think he's gonna put in there? Source port number and destination port number. Now, the source port number could be a port number that the application is using, or it could be a random number. But either way, if he's using port numbers, he's going to have a destination port number. Doesn't mean he's going to have a source port number that he defines, but he will have a source port number, and if it's not defined, it will be random. And Windows would just choose a random one. So the source and source port numbers and the destination port numbers will sit here. And that's good to know, because whenever this traffic goes over to PC2, PC2 will look at this header information and say, oh, okay, where are you trying to, who are you trying to communicate with? Oh, you have a particular destination port that you're trying to communicate with. Let me go ahead, see if I'm listening on that port. I am. Come on in. I'll let you come on in. Then that information gets sent down to layer 3. Now it's time for layer 3 to build his header information. In that header, he's going to put the source IP and he's going to put the destination IP. This is golden. Golden information. The routers need this information. It gets handed down to layer 2. The layer 2 information will say, okay, I'm going to put the source MAC and the destination MAC. Very good information. Switches need this information when they're forwarding data on. Then all this information, this data with all these headers, gets put onto the physical. And the physical will actually take all this information, these ones and zeros, and convert them into bits. What type of bits? Wire bits. Electricity bits. However you want to say it. It converts it into electricity. That's what it does. Now, if you look at the presentation, if you go back up, you can see that it makes sure that the data is presented correctly during communication. The last thing we want to make sure is that data is getting corrupted or not being presented right as the information is going back and forth. And it tells you it deals with formatting and translation between formats. That's nice to know. If we have different types of formats. And if that transport layer is able to take one format and convert it over to another to make it more presentable, that's fantastic. Look what the session says. It establishes, maintains, and terminates, which this will be tear down or terminates, my sessions, my logical communication between the two devices. It also syncs and manages the presentation information. See how this one works with this? A rule of thumb is to say that the lower levels always work with the upper layers, and the upper layers always depend on the lower layers. You could look at it that way. But it syncs and manages the presentation information between the two hosts. Make sure that that information is understood on both ends. The transport layer. Look what this says. It splits the data. These are the segments I was talking about into segments. It reassembles the data. Didn't I tell you that we can actually reassemble that data with the 1, 2, 3, 4 as I was doing on the other side? It establishes, maintains, and terminates the virtual flows. So I might have said that sessions with virtual connections, yes, they are this logical connection between them. And in that logical connections, we have what's called logical flows of traffic or virtual flows. So if I have an IP address of 192.168.1.1 and I'm communicating on port 2001 and my traffic is going to 192.168.1.10 to port number 2001, this is my flow. If I solve this whole thing will be a flow, a virtual flow. And we would have this virtual communication between these devices using an IP address and a port number. What else with the layer 4? This is where we use our TCP or UDP for communication. It does flow control, which we're going to learn about that flow control. As errors, retransmission. Now, retransmitting has to deal with the flow control. Notice in our TCP, we have segments, which is the same way we talk about up here, splitting it in segments. Sequence numbers, which is what I was telling you about the sequence numbers, to make sure that we are getting the data with the acknowledgments. And remember, PC2 will say to PC1, I'm expecting this particular data with this sequence number. And if that's not there, or if it's the wrong number, then PC1 will resubmit that data. All cool stuff, because TCP is guaranteed delivery, which means we're making sure that this data is getting from point A to point B. So we got some overhead. UDP means best delivery, man. I'm going to send it out that interface, and I hope it gets there. It's like throwing something out in space and just saying, man, I hope you get to the moon, and still using thrusters to make sure we get there. Our network layer, let's see what that says. Our network layer says it's responsible for selecting the best path to the destination. This could be kind of misleading because it's the router's job to make sure he's routing the information correctly. So if the router gets the information, he's going to look in the information that's put in the layer 3 header. in the layer 3 information. And he's going to look in his own table and say, I see the destination IP address here in the layer 3 information, in my layer 3 header. I see that information. Now let's find out what interface I need to go out of to get to that data or get it to its destination. So router 1 will use the destination information in here to make a forwarding decision. IP addresses are used here. IP addresses are layer 3. We call these packets.